Okay, so this is Mr. LaBelle here, and I'm just going through the complex numbers, solving quadratic equations, and solving nonlinear systems and polynomial operations test. I'm going to focus on the first part, which was Unit 8, complex numbers. And I'll do all those questions in these videos, and then I'll do another video for the other sections. So this is complex numbers, Unit 8. Question number 4. Let me just get the right color here. Okay, so this is question number 4, and I don't like how thick that is. Okay, question number 4, and it was 7 minus parentheses 5 plus 6i minus 4 minus I. And remember, we wanted in standard form. In standard form of a complex number is a real part, A, let's call it, plus or minus an imaginary part, which we're calling BI. It could be a plus BI or a minus BI. So that's what we're looking for. And so if I do this, I'm going to go this negative sign. Let's go back out of there. This negative sign is going to distribute to the 5 and the 6, and this negative sign is going to distribute to the 4 and the negative I. So you get 7, doesn't change, minus 5i minus 6i. Actually, that 5i is wrong. It's just 5. Okay? And then we're going to get minus 4 plus I. So what we need to do is combine like terms. So I'm going to circle the real numbers. So real numbers are right there. We just do normal operation with them. 7 minus 5 minus 4. And that gives you negative 2. And then in red, I'm going to put a box around the imaginary parts. Okay, and that gives you negative 6i's plus 1i is negative 5i. Okay, so there's number 4. Okay, so the next question in Unit 8 was question number 5. And number 5 was 2 plus 5i over 1 minus 3i. And it might be easier if I just put these in parentheses. You don't have to. But in order to get the bottom, again, in standard form, you can't have i's in the denominator. So it has to be a plus or minus bi. So what I'm going to do is use a fancy one. I'm going to multiply the top and bottom by 1. But it's not going to be in the traditional sense. It's going to look like this. It's going to look like the conjugate, the complex conjugate. It's the same numbers, but it's going to have a plus sign in the middle. In the advantage, and whatever I do to the bottom, I have to do to the top. There's my fancy one. Whoops. Does those weird things on near the top. And, okay. So there it is there. Now what I need to do is distribute. And so I can do FOIL first, outside, and then I'll do a different color. Inside, last. And it turns out I don't really need to do all that because I know it's on the form of a difference of squares. So I get 1 squared minus 3i all squared. That's an I. And I should put it in there. Okay, and the top I do need to do FOIL. So I'm going to go 2 times 1 is 2. I'm going to go 2 times 3i is 6i. I'm going to go 5i times 1 is 5i. And then I'm going to go 5i times 3i, and that's 15i squared. These are all i's there. Okay. So I've got that there. I'm going to have to combine like terms. Now remember, there's a couple things to remember. I squared is equal to negative 1 by definition. Okay, so let's keep working at it. So I'm going to come down here and work down here. And I'm going to get, on top I'm going to get 2 plus 11i, and that I squared is negative 1 on the 15, so right here, that's negative 1, so this is really negative 15 over 1 minus 9i squared. And we already talked about that. This is really negative 1. So we're going to get negative 13 on top plus 11i's over 1 plus 9, which is 10. So I'm going to get negative 13 plus 11i, and I'm going to divide both parts by 10, because this part right here, remember, 1 plus 9 is 10. Okay, and that's in standard form. You have it separated with the a plus bi. So that's in standard form. Okay, number 6 in the imaginary complex numbers section was 2 minus 13i times 2 plus 13i. Now you're welcome to go ahead and do your FOIL and then go. Okay, you're welcome to do that, but we also know that this is a difference of squares, and you're going to get, and we're going to remember that I squared equals negative 1. And so it turns out when you do this part here, negative 13i plus 13i, you're going to get an I squared, and a negative times a negative is a positive, is a negative, but I've got a negative 1 there, so it's going to turn positive. So it turns out I'm really going to use this rule. A plus b squared, I'm using this rule in reverse, is a plus bi, a minus bi. And it goes a little faster, and I have this part here, so I'm working that way. So I really know that this question is 2 squared plus 13 squared. Well, 2 squared is 4, 13 squared is 169, and that gives you 173. And as long as you remember that I squared equals negative 1, you can get that answer. Okay, so number 7, 8, and 9, a lot of people had trouble with it because they forgot what the absolute value was. So the absolute value, when you're dealing with it, so I haven't done 7, 8, or 9 yet, but this is the basic idea. Here's your imaginary axis, here's your real axis. Okay? When you have a point over here, its absolute value is that distance there. Okay, but how do you get that distance? Well, we break it up into 2 parts. So the red part is the x-axis, and the blue part, it's not really the x-axis, it's the real axis, and the blue part is the imaginary part. And we know that we broke it that way so we have a right angle there, and we can use Pythagorean theorem. A squared plus b squared equals c squared. Okay? So we're going to use Pythagorean theorem. And it turns out, remember, this is the absolute value, which is the distance from 0. So I'm going to use c squared equals a squared plus b squared. So it turns out c is the square root of a squared plus b squared. We discussed this in class, so it's about remembering the definition. Now usually what it is you'll have a complex number that's a, let's say, plus bi, and so you don't care about the I. In other words, you poke the I out when you do this. You poke the I out and you'll get what you really need. You really only need A and B to find the absolute value. And we usually don't use the letters C. We usually say Z is the complex number a plus, or it could be a minus bi. So if we want its absolute value of that, then we're going to use the absolute value of z is the square root of a squared plus b squared. And you'll notice we poked the I out and it's no longer there. We just basically do Pythagorean theorem. And that's going to show that 7, 8, and 9 are super simple if you remember that definition. So I'm going to go to the next screen and do that. Okay, so here we are on this next screen. And here's number 7. Number 7 was -4 minus 3i. So if I want the, and that's, we'll call that z, then the absolute value of z is the square root of -4 squared plus -3 squared. And you notice there's no I there. And that turns out that's 16 plus 9, and that is the square root of 25, which is 5. Here's number 8. They gave us 2 minus 9i is z. So I'm going to get the absolute value of z, the square root of 2 squared plus -9 squared, which is the square root of 4 plus 81, which is square root of 85. Now you should try to simplify that. It turns out the best thing you can do is the square root of 5 and the square root of 13, which doesn't get you there. So so I don't really need that. This is the right answer. This is the right answer there. Okay, and the last one was number 9, and it was square root of 5 plus square root of 7i. So that's z. So I'm going to take the absolute value of it. Whoops. We get the square root of 5 squared plus the square root of 7 squared. And you notice again I keep poking out the i's. So that is the square root of 5 plus the square root of plus 7. They go away, the square roots, when you square, and you get the square root of 12. And unfortunately that's not simplified. That's the square root of 4 square root of 3. So the absolute value, I don't like that, is 2 root 3. And there's your final answer on those ones. Okay, so number 22 is you're supposed to find the quadratic equation with the roots. We need to work backwards. And so quadratic equation, you remember, is y equals ax squared plus bx plus c. Okay? And so we need to know a, b, and c. We also know that we can use the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. So what I would like to do is look at the form of this answer here. It was -5 plus or minus 2i. Well, when we look at this, here's the plus or minus right here. So we know that this part here must be the part after square rooting. Okay? So this is going to be the square root of b squared minus 4ac. That's going to be hard to figure out unless we know 2 of the 3 variables. So then we're going to look at the front. So I'm going to change the color here. On the front here, in front of the plus or minus is -b. Oh, well, that's convenient. That's -b equals -5. So b must equal 5. That's important that we have that, because that gets us one of the numbers that we need. The other part is the little bit trickier. It's not as obvious. Okay, I'm going to circle the 2a. Well, the 2a, in order to get that, it looks like this question has been divided by 1, because that would get you the same answer if you divided everything by 1. So we know that when that's the case, 2a has to equal 1. In order for that to be negative 5 plus or minus 2i with no denominator, it must be a denominator of 1. So we'll divide by 2, and we'll get a equals a half. Again, it's really important because now we not only have that one, but we also have a. And we can solve this thing. So we can say, plus or minus 2i has to equal the square root. Now we know what b is, and we'll square it. Minus 4, we know what a is, and we don't know c. That's what we're going to have to figure out is c. Okay? So let's put them in here. I'm going to put them in black. So b is 5, and a is a half. And we just solved this thing. Well, it's a little... I don't like this square root here, so I'm going to square both sides. And I'm also going to simplify. So that's going to be 4i squared equals the square root, it's no square root anymore because we squared, that's why we squared it. We get 25 minus half of 4 is 2, and then you've got the c there. Now again, what is I squared? I squared is negative 1. So we actually have negative 4 here equals 25 minus 2c. So I'm going to subtract 25 from both sides. And I'm going to get negative 2c equals negative 29. Divide by negative 2. And I'm going to flip it around. C equals 29 over 2. I'm going to finish on the rest of the page. But we've got these three values. So I copied those down so I could have more room here. There's what we had. So I'm going to put it into y equals ax squared plus bx plus c. And then I'll just have to rearrange it to get the quadratic, to get it there. And so I'm going to get a half x squared plus 5x plus 29 over 2. We technically have a quadratic equation. It worked in the quadratic formula, so you can have it as y or 0. And I'm going to multiply everything by 2, so I'm going to get x squared plus 10x plus 29. And there is one possible answer. This is another possible answer I would take. Okay? You might even have this multiplied by, you could even have this thing multiplied by 10 if you wanted. But those are the most basic two forms that you're going to see in the answer. So that was number 22. So here's this, this is number 30. This is the last question that was on Unit 8. Okay, and this is out of a challenge problem. And I added some parentheses to help us see that this is really a quadratic equation with ax squared plus bx plus c. And what we have here is here's a, here is b, and here is c right here. Those are our values. And if we're supposed to solve it, then we just need to put it, one option is to put it in the quadratic equation. It's not going to be easy to factor. You could try to complete the square, but I think it's just quicker, or just, you might as well go straight to the quadratic formula. So remember the quadratic formula. This is where you want to kill the variables, but I'm going to say it, but I'm going to write blanks in. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So let's put, I'm going to pause it for a second. I'm going to put all the numbers in. So I'll let you, if you can put them in, you can try it. So hopefully you got them in like that. Now I just got to be careful with all my algebra and my foil. I'm going to change the color here. So I'm going to get negative 4i. We'll deal with that later. There's nothing really to do right now. And I'm going to have to be careful with all the work under the square root. So 4i squared is 16i squared. And I'm just going to leave the minus 4 here. I'll deal with that later. And when I have to do FOIL, so I'm going to go 1 times negative 2 is negative 2. 1 times 2i is 2i. I times, so there's my, so that was first and outside. Now I've got inside, negative 2i. And then you've got I times positive 2i is positive 2i squared. That's what's there. And that's all over 2 plus 2i, if you go like that. And some people won't do that right now, they'll save it for later. So we got that there. Now, again, key, I've said it all the way through, is you have to remember that I squared equals negative 1. So it turns out, here's a negative 1, so this whole thing is negative 16. So I'm going to write negative 16 there. Okay? It turns out we got lucky, plus 2i and negative 2i cancel out. So all I really have to deal with is minus 4. Actually, I'm going to change the color here. Minus 4 times, and I've got negative 2. And again, this is negative 1. So this whole thing is negative 2. And I've got negative 4i up front, all divided by 2 plus 2i. So what happens here? When we get a lot of nice things happen. We get a negative 4i up front. And it turns out this piece, let's write it here, negative 16, and this here is negative 4 times negative 4, which is positive 16, all over 2 plus 2i. Well, again, negative 16 and positive 16 cancel and give you 0. The square root of 0 is 0, so adding or subtracting doesn't change it. And we get to this nice answer, or relatively nice answer. X equals negative 4i over 2 plus 2i. Now that's actually not simplified, but if you got that far, you got some marks, because that's a lot. So you got some points there, because that was very useful. So I'm going to switch the screen here in a second. I'm going to write that over here. X equals negative 4i over 2 plus 2i. Now, if you're really on the ball, you're going to see that you can divide everything by 2. So divide this by 2. And you can divide this by 2. You don't have to do that right now, but it sure makes life easier down the road. I'm going to get negative 2i over 1 plus I. Well, I can't leave I on the bottom, so just like we did earlier, I'm going to use the conjugate. I'm going to multiply by a fancy 1 minus I over 1 minus I. Put that in parentheses. And that gives you, again, this is going to be 1 squared minus I squared. And this is going to be negative 2I plus 2I squared. And I squared, remember what we said, is negative 1. Okay, so let's do some simplifying here. Got negative 2 negative 2i. And on the bottom we got 1 minus negative 1, which is 2. And we've got negative 2 minus 2, sorry, negative 2i minus 2. Again, divide by 2 to everything, and you'll get 1, 1, 1. And my final answer is x equals negative I minus 1, which isn't in standard form, so usually it's negative 1 minus I, because you want it as a plus or minus bi. And there's your final answer. And we are done correcting Unit 8.